Hey guys, welcome to my channel. Today I'll be discussing about certain MATLAB mistakes that should be avoided while you're plotting graphs, and specifically related to vectors or matrices for that matter. And here today I'll be discussing about a function, the function which really led me to do this video, and hopefully others also avoid the mistake that I actually did. So this was a function. This function was a culprit which got me confused, and I spent an entire half day trying to understand what happened. So y is equal to x star sine of 1 by x. And as you know, if you all know, if you have ever done calculus, and if you have not done calculus, let me tell you this, the limit does not exist. And why the limit does not exist, I will come to it later, and we don't have to do heavy calculus to understand why the limit does not exist. Okay, this function when I plotted looked like this function, and it got me confused. Is sine 1 by x, x star sine 1 by x equal to sine of x, x star sine of 1 or sine x? And it got me thinking, oh, that's strange. Y would be equal, but 1 by x does not exist when x is equal to 0. So am I doing a mistake or something is wrong with MATLAB? MATLAB just broke, in my case, sorry, OCTAVE broke down. Okay, and OCTAVE is a free source software, so you can use it to plot anything. So why did this happen? Did I do a mistake? Okay, so the first thing is try to understand why the limit does not exist. So I'm just going to shift over to my Python terminal so that I don't disturb anything on my OCTAVE terminal. Okay, so I'm going to do an import math. So if you do not know Python, I'm just going to import this library and say that I'm going to use this method inside that library for calculation. So x is equal to 0.1. If you see, y is equal to minus 0.544. When x is equal to 0.001, it gets 0.000082, and when it's 0001, you're getting minus 3.05, and 4 zeros 1, you're getting 3.574, 5 zeros 1, you're getting minus 3.49 into 10 to the power of minus 7, as you notice, e to the power of minus 0.7, and then 7 zeros, you're getting 4.25, 205 into 10 to the power of minus 8, 8 zeros, 9.316 into 10 to the power of minus 9, and uncounted zeros, you're getting minus 9.94 into 10 to the power of minus 25. So as you can see, it's not really touching the 0. So 0 is like, don't touch me, okay, for this function. So it's just hovering around 0. It never touches 0, just goes very slowly towards 0 but never touches 0. And let me tell you, even in infinite time, it never touches 0. This function is rigged for failure around 0. Okay, so given the fact that we understood that, and I've taken the right hand limit for this, you can even take the left hand limit. You just have to substitute 0.1 to minus 0.1, just make it negative and calculate. So it's just approaching from the left side, but it does not exist. So minus 1 to 1, the domain of this particular variable x, it just does not exist, and I'll show it to you in the plot. So now when I plot these three using these subplot and plot commands, so subplot lets me know that okay, there are going to be 3 rows and 1 column. So I can put 3 graphs into one picture. So here you can see this is my y function, this is my z function, this is my w function, and y and w are looking same, and that got me confused. How can sine of 1 by x into x be equal to sine of x into x? That's impossible. Even mathematically, that's completely impossible, right? And it got me thinking that I am doing something wrong in MATLAB in the code, which is causing this y to look like w when y should be looking like this, right? Yeah. So this is where I found out something called MATLAB operators, or people who know MATLAB very well know MATLAB operators. Okay, so I've just copied some sentences here. So here, if you see slash and this slash do exactly the same thing, but it just does this guy / b star inverse of a, and this guy is just inverse of a star b, and this is what I was using, inverse of a star b. And when I take an inverse of 1 in this case, MATLAB, I've been saying MATLAB, quite sorry, it's OCTAVE. So OCTAVE or MATLAB, anyway, both of them have the same behavior in this case. So inverse of a, that is inverse of 1, So inverse of 1 is nothing but the identity matrix, and the identity matrix will have the same dimensions as that of B, that will be set to m cross n. And if you all know, when you multiply an identity matrix with another matrix, you just get back the same matrix without any change in the matrix. So you're getting back B in this case, and in this case it's B star inverse of A. So if you're done slash, the forward slash, maybe you would have just taken the inverse of A into B. Okay, so this is how things have been working. So that is why, if you take another example to show how it works, if you take A is equal to minus 5 to 5 in the range 5 to 5 with step size 1, you're getting this as a value, and B forward slash B is equal to 1 by A, sorry, backward slash B is equal to 1 by A, you're just getting back the same matrix as the definition says. And C is equal to 1 dot slash A, you're getting what I expected and what I had in mind, right? So this is what I had in mind, and but I got this and started thinking why this function y and w was equal, right? Whereas I should have just used this for vector division. That means each element would have just been 1 by ai comma j, and I've got 1 by of that like this, minus 0.02 whatever value x holds as a vector, and I'd have got the correct plot where it just goes around to 0, that is just going to infinity here, right? It never touches 0 but is just hovering around 0. That is the magic of this function. So given this is the point, we should never be doing this until unless you're just doing a scalar division. Just go for it and be careful of it. Always know what your dot slash or forward or backward does. It is for vector. Even this dot star that you're seeing here in all these three functions that you're seeing, dot star is nothing but vector multiplication. You should be using this when x is your vector. You shouldn't be using this when x is just a scalar quantity like 1, 2, 3, 4 or minus 4 or some constant for that matter. Okay, so you should know this very precisely when to use dot star, dot slash, this one. So please read it up before you actually code and avoid the mistakes that I did. Sorry, didn't clear up what was there. So this above was just a display of x and y. And anyway, let's get back to this. So this should be avoided. So you know that the y part should be avoided, the backward slash. Okay, so please avoid this. Do not use this if you're using a vector. Always remember that. You always use a dot next to the operator that you're going to actually use, and for a vector. If it's a scalar, just a constant, if x is equal to 1 or something like that, just one number, do not use the dot at all. Okay, it is similar to what you would have a dot b in your physics, like the scalar product a dot b. So just remember that a is a vector and b is a vector, right? It's the same thing here. So x is a vector, sign of 1 dot slash, the forward slash should be also a vector, so that's why I'm going to use a dot. So hopefully you have understood when to use a dot, when to not use a dot, and you can basically learn from this and try to make your code better and less error prone as you go on coding in MATLAB, and also use MATLAB or OCTAVE. Sorry, so I've been using MATLAB for a long time, but OCTAVE is what I chose because it's free, so open source, and you can just use it anytime. Okay, so and these tools can be used, OCTAVE or MATLAB can be used to basically get you an intuitive idea and graphical idea of what you will be learning in calculus or linear algebra. So please go ahead and use these tools because they make you understand things better and also avoid such mistakes that I have done. And hopefully this information was useful, this video was useful for you to understand what mistakes should be avoided. And leave your comments below for anything that needs to be changed in the way I'm talking. Yeah, and the way of talking is like a bit confusing, but yes, it's always an improvement. any other video content that needs to be provided, or anything, any other topics that I'll be covering. But anyway, I'll be covering a MATLAB basic video for people out there so that they can really understand how these things work, and I will be in depth about it, because I don't see so many YouTube tutorials actually giving the complete information, but I will be giving the complete information that is required for matrix operations and what are the operators that you need to be using when what. Okay, so this is just a basic idea of what I went through, and I could have avoided if I had known how it works. And thank you for watching this video. Hope you enjoyed this. Never say that maths is not interesting, but yeah, hopefully this you enjoyed, and please come back for more. Thank you for watching. Bye.